My name is Andrew Neish. I am the Director of Signals Architecture here at Xona Space Systems, and I'm also one of the co-founders of our company. My role is as a technical lead in all things signals related here at Xona Space Systems. So I lead a team of highly talented engineers that design our navigation signals from the ground up. So I'm talking from baseband design all the way, and center frequency selection and all of that, all the way up through packet design and our data structure. So I work closely also on the spectrum regulatory side, since that provides a lot of input to the designs for everything that I just mentioned. And I also help produce a lot of those technical compatibility reports as we're coordinating with other operators in the band. And so we work quite often with the FCC, NTIA, and ITU, and other more specific federal agencies for that. Our mission is to maximize the positive impact of modern technologies. And so our method for doing that is provide the world's most accurate and robust location service to enable devices to operate safely in any environment anywhere on Earth. So here at Xona Space Systems, we're building and launching a constellation of low Earth orbiting satellites that will deliver navigation signals to users, very much in a similar way to how GPS does it today. So at its core, Xona is providing that navigation service that will be powerful, protected, and precise. So there are probably three main domains where navigation services can lie in space. So that first layer, the closest layer, is low Earth orbit, which is typically anywhere from a couple hundred kilometers to low 1,000 kilometers or so. Then you have medium Earth orbit, which is actually where GPS and all the other GNSS exist today. And then you have geosynchronous or geostationary orbits. And so these are orbits where their period of evolution around the Earth matches the rate at which the Earth is spinning on its axis. In navigation, what we care about is first global coverage. So when GPS was being designed, they cared about making sure that the system would be available globally. And then also in navigation, what we care about is having measurements from multiple sources that are at different points in the sky. So if I want to make a measurement of my position, it doesn't help me if there are 12 satellites in the sky and they're all in the exact same location. What I need is a diversity of measurements so that I have some information about where I am in this axis, and all these other types of axes. And when GPS was actually being designed, they were considering everywhere between low Earth orbit and geosynchronous geostationary orbits. They threw out geosynchronous orbits because they would like to use this system globally. And if you have a geostationary satellite that, say, exists over the Pacific Ocean, you don't have any ground sites over the Pacific Ocean. So it's hard to then communicate to those satellites to upload things that you needed to upload. And as you get closer and closer to the Earth, from a satellite's perspective, the amount of Earth you can see becomes smaller and smaller. If you wanted to build a system like this, low Earth orbit can be challenging, especially when you're designing it in the 70s, because you just simply need a lot more satellites to do it. So GPS found a happy medium there where they exist in medium Earth orbit, about 20,000 kilometers away above the surface of the Earth, where they do revolve around the Earth approximately about 2 times per day. So you get that kind of global coverage, and you only need, technically only need 24 to be operational as a system. They currently, I think, have 31 operational. Xona's system will have anywhere from about 260 to 300 operational satellites in low Earth orbit. And that's simply because of that coverage. You need more satellites in low Earth orbit. Now, but it's funny though, today in 2024, when you're saying a 300 satellite constellation, that's a number that's not balked at anymore, right? We see SpaceX launch that many in a year, much more than that in a year, in fact. We use ground-to-space links, space-to-space links, and space-to-ground links. So the space-to-ground links I've already mentioned with regard to our navigation service. The ground-to-space links are incredibly important for telemetry and command of the spacecraft. So as they're going over some of our ground uplink sites, they will have control inputs put to them so that they can control their attitude and do any station keeping maneuvers to keep them in the proper orbits. And space to space is an interesting thing. You may not think of this too much, but our spacecraft do use Galileo and GPS when they are available. And so this helps us calculate the position and clock state of our satellites to a very high degree of precision. Where they might, so Galileo and GPS may not be kind of completely necessary for the system to function. When they are being used, that is a space-to-space link. You are just in a low Earth orbit at 1,000 kilometers receiving something from a medium Earth orbit at 20,000 kilometers. The most important frequency ranges to our organization are the ranges contained in L-band and C-band. So L-band is around 1 to 2 gigahertz. C-band is in that 5 gigahertz range. And the reason why these are the most important spectrum for us is because these are the regions that are approved for radio navigation satellite services. Radio interference in these bands, especially in peacetime situations and locations, is typically due to either malfunctioning equipment or kind of unwitting use of devices like PPDs. PPDs are personal privacy devices. What they do is essentially emit a jamming signal in that range. So if you are trying to, let's say, protect your location from being tracked by your boss because your vehicle or something has a GPS tracker in it, folks can sometimes plug these into their cigarette lighters. The problem with that is that even though these are relatively low power devices, so on the order of milliwatts, by the time the GPS signals reach you here at Earth, their power is 1/millionth of a billionth of a watt. So that's very, very, very low power. And so it turns out that if you plug in this kind of milliwatt jammer into your cigarette lighter, you can take out an entire city block sometimes, or even wider. So that's what I'm talking about by unwitting use of these types of devices when people aren't aware that they're causing much more disruption than they realize. So how we kind of address that with our system is we actually provide much stronger signals than currently existing signals. So by the time they reach you on Earth, you'll be able to survive through many of those types of events. Ideas really only go so far as they can be successfully communicated. So you might have the best idea in the world, but working on the best way to communicate that idea to different people with different backgrounds is very important to bring that idea into reality. And so a large part of Spectrum is working in policy and working with folks who have a very strong policy background, but don't necessarily have the strongest technical background. So being interdisciplinary, not only in, let's say, the hard skill sets of the different technical problems in your domain, but I would say it's also very important to work on effectively communicating what you're working on, the problems you are trying to solve, and also better understanding things from a policy perspective to work with folks to get things done. What we've seen happen over the past 20 years is an explosion in new space. So I'm an aerospace engineer by trade, and so that's a lot of what I focus on, but we've seen an explosion in constellations for communication systems. We've seen an explosion in systems for Earth observation systems, all of which heavily use radio spectrum in many different bands. And that seems to really only be picking up more and more pace. So there are a lot of opportunities in the space. I would plug Xona Space Systems as being one of the leaders, or at least the thought leaders in this space. And so if you are interested, definitely come and reach out to us. We're pretty responsive, and we're always looking out for very talented and motivated individuals.